Hey guys, kicking off lesson 32. I believe this is our last topic that we're dealing with matrices. And by the end, you will see what a great thing matrices can be and how easy they can make some of our former difficult problems. But the big thing that we're dealing with today is one, dealing with inverses of matrices. And then the second thing is just solving problems with matrices. So since algebra, we've been solving for x and things like that. And now we're going to be doing that where x might look like a matrix. So a blank is a rectangular array of elements. That would be a matrix. And then that second part, multiply the matrix by the scalar. This was one of the first things that we did. Remember, if you have a scalar, that is simply a multiplier. That's kind of like a coefficient where we multiply each of our terms inside that matrix by 5. So our new matrix would be 15, negative 10, 25, and 60. Okay? So our first new concept, we're going to have quite a few of them today. The first one is dealing with inverses. Okay, so if A is a matrix that's just n by n, that means it's any square matrix. And I, remember I is the identity matrix, is the same size, then A times I is equal to A. We already know that. So today we're going to look at what an inverse matrix is. And that's when we multiply two matrices together and we end up getting the identity matrix. If you don't remember what the identity matrix is, the identity matrix is when this would be a 2 by 2. We would have 1, 0, 0, 1. And then just to show you a 3 by 3, it would be 1, 0, 0, 0, 1, 0, 0, 0, 1. So you have all zeros except for a diagonal 1 pattern. And then for notation's sake, we multiply A by the inverse of A, which is A to the negative 1. That's what our B value or our B matrix would be. It would be our inverse matrix. So if we're going to determine if these two are matrices, that means that we are multiplying these two together and we're going to get the identity matrix in the end. So if you would like to use a calculator even for something like this, I'm totally fine with that. I'm going to do this single one by hand, and we're actually going to use calculators quite a bit throughout this lesson, so you might want to go and grab one. So remember, when we are multiplying matrices, it's all about going over and then down. So we start with 2. 2 times 2 is 4, plus 6 times negative 0.5 is negative 3. And now that's the top left element. Then again, we do 2 times, now it's going to be negative 3 is negative 6. And 6 times 1, so plus 6. Now we'll jump down to the bottom left element. That's going to be 1 times 2. And then 4 times negative 0.5. So that's negative 2. And then it's going to be 1 times 3. So that's negative 3. And 4 times 1, so plus 4. So if we simplify this guy, we get 4 minus 3 is 1. Negative 6 plus 6 is 0. 2 minus 2 is 0. And negative 3 plus 4 is 1. So that means since we got the identity matrix, these two matrices are inverses of one another. Okay, now this, make sure that you write this down. I know it looks super confusing, but this is how we find the identity matrix. So what this is we take our matrix and we have 1 over, this is the determinant, and then we multiply that determinant, which remember is a scalar, by our elements rearranged. So we have D, negative B, negative C, A. So normally it would go A, B, C, D, and you rearrange what those numbers would be in that order. So again, this would be a really good thing to write down. So let's take a look at what this inverse, the inverse of T, would be if it exists. It is possible that it might not exist. So the first thing I'm going to do is the determinant, but remember, so this is A, B, C, and D. So the determinant is just multiplying across, so that's 3 times 2 is 6, minus negative 1 times 4 is negative 4, so that equals 10. So I need to multiply by 1/10 of my matrix rearranged. So D is 2, negative B would be negative 4, negative C would be a positive 1, and then A down here is a 3. So I need to multiply each of these things by 1/10. So that means I'm going to come back up here. 2 times a tenth would be 1/5. Negative 4 times 1/10 would be negative 2/5. 1 times a tenth would be a tenth. And then 3/10. Okay, so this would be my identity matrix. So you can always check it, and I would check it with a calculator, but I can multiply that 1/5, negative 2/5, 1/10, and 3/10, multiply that matrix by the original T matrix, and we would get the identity matrix. So that's actually how we would do that. Maybe I will do that real quick. So this is definitely going to be the longest. Second matrix, remember we're going into this. This is a 2 by 2. We have 3, 4, negative 1, and 2 is my first matrix. And then the second matrix, go back into edit. 1/5 is 0.2. Whoops. 2 by 2. 0.2. Negative 0.4, 0.1, 0.3. So all I need to do is multiply these two things together. So I have A times B equals 1, 0, 0, 1. So that's the identity matrix. So that's how we can always check to make sure that that actually is the inverse. Okay, that's it for the first video. If you guys have any questions on that, I know it can be a little bit confusing, but feel free to go back and look at a couple of those examples again, or if you need to ask questions, please feel free to do that as well.